at a two-part video today. The first part is just collecting T2 data using the EFT-90. I have a sample in already, so I'm going to just start the experiment. We'll go to the Proton pull-down menu under the relaxation and rate experiments and just choose the T2. Similarly, I could just type T2 at the command line. We'll give it a name, Tom. Do you have TMS in your sample? Yes. If you've previously run a T2 experiment and you're happy with the list that you created, you can just open that list here. For me, I'm just going to create a list. It'll query me. How many delays do I want? If this is your first shot at it, I recommend just 9 delays so that you can get it over with quickly because you may have to run it again. Then it asks you what your expected T2 is. I'm going to put in 2 seconds. At this point, it's created the list. I can continue the experiment, or I can look at the list. Let's take a look at it. There's the 9 experiments that I told it to take, and then the number of delays. The first one is always 1/10 of the number you put in. 1/10 of 2 is 0.2. The last one is always 8 times the value that you put in. So that's ready to go. We'll continue the experiment. Notice in the smart window it says acquiring T2 data. It tells you what the first delay is, how many 180-degree pulses it's going to do. The total time per experiment is 20 seconds plus that little T2 time. So the first one is 20.2 seconds. The last one is closer to 36 seconds. So altogether, this is going to take about 5 minutes to acquire the data. If you look at the data after the first scan, that's going to be the highest intensity spectrum right there. As it goes along, we're going to start losing coherence, and the spectra are going to get smaller and smaller as time goes on. We're going to jump ahead to the final experiment right now. Okay, now as we're coming into the final couple scans, you'll notice that the data, the peaks on the screen have gotten measurably smaller. Notice that this is firing off 26,000 pulses. The data is going to auto-process when the experiment is finished. It's going to ask you for a line broadening value. Because this is Proton, if you want to, you can use a value much less than 1, 0.1, 0.05, but in general, I don't use any line broadening for my experiments. So you notice the data comes up in stack plot mode, and it's slightly offset so that each peak is a little bit offset from the one before it. And so we're going to process this one peak at a time. So I hit enter to get out of stack plot mode, and I will zoom in on one of the peaks. I'll hit enter to get out of zoom. I can type the 2-letter command SP stack plot so I can see the different peaks on screen. I can hit W to whitewash it so that you can't see through the grid. None of that matters. It's just some functionality in the snap program. Hit enter to get out of that program. And then there's a combination of 2-letter commands that you're going to use. The first 2-letter command is GR, get relaxation data. That goes through and reads the integration of everything that's on the screen. You'll notice that I probably am zoomed out a little too far. I should be in closer to the peak, but we'll deal with that in just a second. The second 2-letter command is DR, display relaxation data, DR. And you'll notice you'll see the different square boxes on the screen, and the data hasn't been fit yet. You can come up here and under the edit or fit pull down menu, you can optimize the curve fit. And you notice down here in the bottom right hand corner, it tells you what the value of I know that it says T1, but this is the T2. So the time was 1.92 seconds. You can hit O a couple times and it'll change the value in the last few digits, but in general 1.927 is your T2 for this. Resonance in the molecule. Let's try something. Let's zoom in a little bit closer and we'll type the commands in again. GR, DR, and then O for optimize. We'll hit that a couple times. Notice now that it says 2.74. The reason for that is we're now, instead of looking at some baseline and the peak, we're looking at mostly the peak. This is probably much closer. So in general, when you're processing T2 data, zoom in on the peak like you were going to integrate it, not like you're just showing it on the screen. Let's do another slice. By the way, that showing on the screen right now, that's the last spectrum that was collected. That's some are up and some are down. I'm going to go back to the first slice so you can see what it looks like. Let's zoom in on this other methyl group. And what I usually do is I take a broad swipe and then I come in closer the second time so I can really see where I'm putting it. I'm going to do a stack plot to see what it looks like. GR, DR, O, O. 2 seconds. So within this molecule, one of the resonances is 2 seconds. One of the resonances is 2.7 seconds. Not too surprising. Let's do the methyl group. GRDR O 2.32. So within this molecule there are several T2 times. The guess that we use, 2 seconds, that's more than adequate for what we did here today. You wouldn't have to repeat this experiment if you didn't want to. However, if you do a few more data points, you may get slightly different results, but in general, the values that we got are reasonable.